G'day, in this video I'm just going to walk you through the process design for this leachate treatment plant here on this old landfill. So a landfill or a tip is where waste is stored and managed, often containing a variety of materials like household waste, industrial products and organic waste. As the waste decomposes, it produces a liquid called leachate. Leachate is the contaminated liquid that's formed when rain or moisture seeps through the waste, picking up harmful substances along the way. So we're processing leachate at a rate of 50 cubic metres per day, suitable for trade waste discharge. So the raw leachate from this landfill comes in via this pipeline here, and we essentially just have an actuator which is just going to release the leachate from a pumped main. And we bring it up and over to this raw leachate tank. So once we've collected the raw leachate in this tank, we pump it through this MMF to take out any sort of fine solids before passing it through these granular activated carbon filters for the removal of various groundwater contaminants. These are all sequentially fed and backwashed via this backwash tank. Once we've been through the collection, filtration, backwash storage, it comes here to this break tank where we feed the anoxic tank for the start of the biological process. So here we have our anoxic tank followed by our nitrifying reactor, then our sequence batch reactor. Once the leachate has been through the filtration and granular activated carbon process, it ends up in the break tank before it's being fed into our anoxic tank. Now, before I explain the anoxic tank, I first need to explain the nitrifying reactor, because this is the first step in a two-step process for nitrification and denitrification. Ammonia is a harmful pollutant commonly found in leachate, and if untreated and released into waterways, has the ability to harm the environment due to its toxicity to aquatic life. Furthermore, ammonia, with its high oxygen demand, has the ability to overload council sewer infrastructure. Ammonia is made up of nitrogen, or NH3N, which we essentially want to remove from the water. This is achieved in the nitrifying reactor, which is filled with millions of microscopic organisms, or bugs. We use a blower to supply these bugs with oxygen, or O2, while we feed the tank with the nitrogen-rich leachate. The bugs then use this oxygen to oxidize the ammonia into nitrate, or NO3N, in a process called nitrification. Next, the nitrate-rich water flows into the anoxic tank. We have return-activated sludge pumps that are pulling from the anoxic tank to the nitrifying reactor and then back, creating a loop. In the anoxic tank, we introduce sucrose, or sugar, to fuel the bugs to help them thrive in their new environment. However, this time, we don't supply oxygen, creating an anoxic environment. The bugs that require the oxygen to survive have no option but to take their oxygen from the nitrate molecule, which releases the nitrogen to atmosphere in the form of nitrogen gas, completing the nitrification-denitrification cycle. So here we are, this is our sequence batch reactor, the final step of the process. Here we're pumping forward again from our RAS pumps from the NR to the SBR, and it's gravitating back. Same thing happening from the anoxic tank to the NR and back. And here we're currently in aeration. After the aeration period, the blower will turn off, we'll go into a settle period, biosolids will sink to the bottom, and then we go into the decant period where our airlock siphon decanter will draw water from the top of the tank to the effluent tank. Our airlock siphon decanter is an Aerofloat piece of proprietary kit, and the way it works is this actuator will open, releasing the air that is trapped in the decanter pipework, and then the clean water will, under gravity, go out via the U-tube to the effluent tank. This actuator will close, and then that will begin a siphon effect. The clean water runs out through the manifold down to the effluent tank. So here above me is the outlet of the airlock siphon decanter. This is a pretty small decanter, it's just made from shed 80 pipe. And then around the back here, we've got more progressive cavity pumps, sending it way up over the hill to the trade waste discharge point, pumping in off-peak times, satisfying their trade waste discharge licence. So by using advanced biological treatment methods here, we're able to process this leachate safely with discharge to trade waste, protecting the council infrastructure downstream and providing this client with the opportunity of processing leachate here on site rather than trucking it off site. If you've got any questions, post them in the comments, and thanks for watching.